Thank you. So I have the mandatory slide for who am I. Those are the games. I've been doing a lot of R&D. I've been doing some R&D that is not particularly graphics rendering programming. It is more of how we present UI to the player, how we integrate it into the game, and so on. I want to. By the way, let's start with this. Who here considers himself a technical person? Can you raise? Okay, so we'll go in depth then. Who of you has been to a game jam? Well, okay, that's good. So games, they have a lot of UI. Although the only UI in this slide is from the presentation, there is some hidden UI here. And this is a game, this is Dead Space. It prides itself with not showing any UI to the player. They just integrate it inside the game. There are also games which go overboard. This Europa Universalis, this is the dream of every Excel person. You go in and play Excel the game. So I'm keeping it short, but I'm going to go in depth in the few things that we're going to discuss. We're going to start with side distance fields. They are going to reappear across the whole presentation. Then we'll do some anti-aliasing with some examples and noises, because whatever you do, you use noises. So what are sign distance fields? Sign distance fields are the distance to a set. This is according to Wikipedia. We don't care about that. Let's consider that there are two types of side distance fields. There are the analytical ones and there are the discrete ones. We are not discussing the analytical ones because computers are finite, but we are going to use them anyways. We'll just get better precision. Wherever I talk about sign distance fields from this point on, I'm talking about distances inside of a texture. They are discretized. You get a pixel, you get a distance to some object from that pixel. So sign distance fields are cool if you have them, if you have an analytical function, but if you don't have them, you need to build them. So how you do that? Well, you run an algorithm on your data. So the naive approach, which I have painted as a huge baddie with O and fourth complexity, it is not so bad. Actually, consider it if you don't need sign distance fields which span your whole data. You just need the local information. You can do that. It is actually sometimes faster. There are CPU approaches because you need, sometimes you generate it for us as, for example, foliage. The CPU versions are quite fast. They are practically linear on your data, but your data is n squared. And then there are jump flooding, the jump flooding algorithm, which we will discuss in depth. The previous ones are like, there, look them up. The jump flood algorithm, it should have some issues. I have never seen those issues. I don't actually know what they are. But if you find one, write to me. I'll find it interesting to discuss it. You can generate it on the GPU. You will spend some memory, but it is like 2 times the memory of your data, so it is fine. Also, you get this log n. You always get it with GPU algorithms. So what you can use them for? Sign distance fields can be used for text rendering. Text rendering is, there's a huge presentation by Valve who discuss how you should keep all your fonts as sign distance fields. You can do a lot of cool effects with them. You'll see that. You can do outlines of objects. If you have made a game, some designer has wanted you to put outlining of things in your game. So you can use that. The cool thing is that you can actually make them pretty much perfect. You can make them configurable. You can make them thick as hell. Unreal uses them for shadows. This is actually quite fast, surprisingly fast, but it burns through your memory also really fast. You can use them for anti-aliasing, that will be later, and alpha testing. In the last year, I have started to consider sign distance fields for anti-aliasing alpha testing as a poor choice because there are better algorithms. But if you do it in real time, if you procedurally generate something in real time, your texture, it will probably be a good idea to do a sign distance fields because it's fast. Text rendering, how we do effects using the previously discussed things. Well, you have the distance to your letters. If you paint them in the same color as your letters, then you make them thicker. If you paint them in a different color, you outline your words, and if you put some smooth step or linear interpolation, you'll get this fuzzy effect. Glow, call it whatever. If you offset this effect and make it less pronounced, you can make shadows, soft shadows. For hard shadows, you can just paint the thing, draw the thing twice. I actually have, by the way, I'm considering calling the presentation shader toy the presentation. We have the Nyan cat. Let's see how you can make the effect using sign distance fields. By the way, this is the distance to the cat. And this is the effect we discussed. We can make it thicker, we can make it thinner, we can make it quite thick. We can actually put shadows using it. Where is my mouse? I don't know where my mouse is. Okay, it's there. And based on your needs, you can put a shadow wherever you want. Also, you can make it trippy as hell. This is an option. Yeah. So this is the worst slide. This is the info dump on how to do jump float algorithm and some developments which you cannot find on the internet because I don't know, nobody talks about this. First thing you need to do is you need to make a stencil. You can do a bit texture or you can do just a stencil buffer, whatever. If you want to do different colors, you need to write IDs, not just there's an object here and there's an object there. Outlining with Z testing is actually not so beautiful. You want the user to see the outline through wall, so disable it. And when you disable the Z test, you get artifacts, of course. So consider your IDs as priorities for your outlining. You see what I'm talking about this, or if I forget to tell you, ask me. There is some information here on how to build it. We're not going to discuss it. No, we'll actually discuss it. You need to do some encoding on your data because the algorithm works on storing your the closest pixel to this particular pixel. So you need to encode texture coordinates in your textures from the ID. So two textures, as I said. If you don't want something to be outlined, you can use the maximum ID and stop it because in the previous point we disabled the Z testing, so it is really hard to stop something from being outlined. Just put geometry which is with a bigger ID and it will hide it. Pictures talk more. This is the scene which we're going to outline. This time it isn't a cat. Those are the IDs that I was discussing. They won't actually be colorful. They will be just 0, 1, 2, 3, and so on. Then you start going through the algorithm, its steps and steps. By the way, this is the hard part, and probably if you decide to implement it, you will need some intuition on how it works. Well, for each point, it just puts 4 points to the maximum distance of it, and asks, is there something written there? Is there an ID? And if there's an ID there, it stores the pixel location. And then you repeat it logarithmically closer and closer and closer. So you get this thickening, and then you get the distance to it. Once you have the distance, you get the outlines. About the thing that I was talking about with the IDs and their priorities, this thing is in front of another one. And you actually need to calculate distance to this one, although it is within this object. This is an issue when you do it on the GPU and you want it to be fast. But once you use the idea that IDs are priorities, it works surprisingly good. So yeah, those are signed distance views. Let's talk about anti-aliasing, because once you do your fancy effects, you see that the alias resolutions are insufficient and so on. There are a lot of options for anti-aliasing, and neither of them works for your procedural geometry usually. There is multi-sample. Do I go back? Yeah, there's multi-sampled anti-aliasing. It's unusable for your case. There is also the image-based things. They might work if you do it, if you put your user interface items inside the game and then you run those algorithms on top of them. Those are your best friends. Come on. Those are your best friends. Try using them. Temporal is actually your worst enemy, because once you get temporal anti-aliasing going for your game, it will mess with all your UI elements because they're procedural. They don't understand the concept of vertices of anything, so you probably need to fight it. And then there are the anisotropic filters, which you also can't use because most of the time your textures will be procedurally generated because this is the presentation, and no anisotropic for you, but you can actually use the GPU tech of anisotropic filtering to anti-alias your procedural effects. How you do that? Well, you use the derivatives. They're there, usually for anti-aliasing, but we exploit them. You can find them as those functions in your shading language. If you are in OpenGL, there will be some more letters here, but you can search it. What it does is pretty simple. Actually, this is really fast. It does only one subtraction. This is a visualization. By the way, derivatives are interesting because they're the main reason why your foliage is slow, because the GPU provides to you derivatives. Those triangles actually are rasterized as bigger triangles. All of those pixels go through the pipeline just so that it can do this subtraction. I'm actually going to say this again. This is only a subtraction, so it will give you the difference of a value to the neighboring pixel. How we use it? Well, we're going to change the order. Yeah, we're going to change the order. We use it this way. You actually get your difference. Once you have the difference, you use it as an estimate on how much space your effect takes. And then you cycle through your effect a bunch of times, calculate it for multiple points inside that area, and you average it out. This produces surprisingly good results. On the left is without this anti-aliasing, and on the right is with it. Sometimes you get analytical functions. It's really rare. The guys who have visited math classes know it, but you generally, if you have that function, for example, this one, you just have a step function. The step function, you say, well, if you are in this range, we are going to draw some white stuff, and we are going to build a grid this way. If you do this, and your pixels fall in those empty spots, you get a white you get no effect at all. And if they fall on the peaks, you will get pretty much the effect everywhere, which is pretty much the definition of aliasing. So we get the integral of this. By the way, the code is quite simple. You just calculate. You get the value at this point of the integral, you get the value at this point of the integral, you subtract it, and then you divide by the area that you have, because otherwise you get a value which is above 1. You usually want to normalize your results. So once you get that, you get this perfect anti-aliasing on the right, and if you do it naively, you get the aliasing on the left. Yeah. Anyways, let's. By the way, I also have a shader toy for this. So let's see it. Yeah, so it makes quite a difference when you move around, especially when you move around. Static pictures don't really give it enough, don't show enough. Yeah, so this is unusable on this screen. Anyways. Noises. Once you try to anti-alias your effect, it will still look crap, because our eyes are too good at picking up defects such as banding and patterns and so on. So you usually put a noise on everything. One candidate of putting noises are just white noise. Yeah, just simple noises from 0 to 1. You can just juggle around your pixels so that they look more natural. But if you have temporal anti-aliasing, this will not work. Other noises are you can actually find colorful noises. If you get colorful noises, you can simulate old monitors. Those are pretty cool, but if you want to do filmic effects, you probably won't be using this noise, because it is single pixel and monitors don't really look like photography. So you get film grain textures. By the way, film grain texture is pretty easy to achieve. You can just take a texture and hard light it on top and stop it from moving, and you get a pretty decent effect. Other noises that you can use are Voronoi. By the way, this is the bread and butter of all noises. Whatever you're using, there is some Voronoi deep down. Also, this uses sign distance fields to make those cells. So the whole thing comes together pretty neatly. Voronoi noises, the biggest use for them that I have seen over the years are using them for caustics in water. They produce like such perfect results. Also, you can go for the really complex ones like Berlin noise. This guy got a bunch of rewards when he invented it. And it is used for pretty much everything, but the most popular usage are quads. You can make puffy things with it. By the way, if you do this, you probably use sign distance fuse and array marching on top of the Berlin noise. By the way, simplex noise. Simplex noise is pretty much Berlin noise, but it looks crappier and it is faster. If you can use simplex noise, use it, because your game will run a lot faster. There is all the usages of simplex noise are the same as the usages of Berlin noise. Then there are the noises based on Fourier transform. Everybody who's doing game development at some point will try to make water for his game. This is like this is a rule, so everybody does water. The water will need to, it has a specific pattern to it, where there are waves at every zoom, at every level that you're looking at it. If you go really deep inside the water, there are little perturbations due to small gusts of wind. If you go really far away, there are wash winds, and so you need something which can be composed together. So Fourier transform are great because you can you can just go deep down the Fourier row, and you can get waters. They look pretty cute. So as I was saying, this is shader toy the presentation. Please, my username is my name, Mitko. You can go and find the demos there. Try it out. You can get inspired by the things there. You can, there is a pattern to building procedural effects. The pattern is as follows. You need the building blocks. You need your SDF functions. You need to know how to anti-lice it. You need to know how to draw your lines and guide the effect and make it actually what it needs to look like. And those are small blocks. You need to build a library in your head, optimally a pretty large library of small building blocks, and learn how to compose them. And in my career, I haven't seen anything better than shader toy for this. You just search the building block that you need, take the code, you can actually edit it in place, and so forth. I have this thinking that the industry has stopped looking into UI being done with shaders. This is a really interesting trend. Everybody who does rendering, he does the fancy stuff like we're going to make screen space shadows, we'll make ray tracing, we'll do the DX ray tracing and so on. And nobody discusses the simple things like how do I put a line inside the game? Just a simple line. Well, you just need to go back in time and look inside books which are from 10 years ago, 15 years ago. People there didn't have the GPU time to do ray tracing, so they did those effects. Also, you can find some of those in more recent things, but usually water. Everybody does water and snow nowadays with those effects. Yeah. So I don't know how much time I have. Plenty. Okay. Let's do questions. I have bonus slides.
Then let's continue with the questions. I would like to start first with one, if you please. Mine will be, how did you get the interest in those algorithms? Did you specifically study them in university, for example, or only through practice? You just wanted to deep down go through the technology and see how they work?
Well, the discussion about building blocks is the key part. Like, when you start making games, you need to show something to the user. And the thing that you're going to show to the user is like your designers will come and they'll say, I need my unit outlined. And then you start thinking about how do I actually outline a unit and how do I do it in real time? How do other people do it? You read through a bunch of things. And at some point, you build such a library of effects that you can go back to your designer and say, listen here, we can do actually something even better. So yeah, pretty much there's pretty much nothing unique in this presentation. Everything is on the internet. This is just a collection of things which are scattered across the web.
Yeah, but they're very interesting. So if there are questions, I can pass the microphone to someone. Oh, it seems not. Would you like to show us the bonus slides then? You have some time.
The bonus slides are interesting. They discuss how to actually think about those effects as building blocks. So in Jagged Alliance 3, there is a huge issue with player visibility. Like, there is too much information on the screen. It is inside the actual game, and users get lost. Sometimes they don't know that you can actually press a door to open or press a sign and it will pop out and say something of interest. Also, this effect that I'm going to show, it helps quite a lot with the actual combat system, where you get inside the combat. You need to know there are your units, you need constant visibility. There are rows, a lot of busy effects on top, a lot of busy geometry on top of it, and the player gets lost. So we needed something to improve visibility. And one of our, actually the lead artist on the game, he said he sent a bunch of Photoshop files to us, and he said, well, this would look good. And the first slide was like he made it in layers. The first layer was, I want to cover the units. I want my allies to be in green and my opponents to be in red. Also, I want my interactables to be in yellow. Then he said, but it looks ugly, so we need to add some transparency on top of it so that we can look inside, but this one still looks shit. Then he said, well, we have this large theme inside the game where it is happening during the 2000s, and the 2000s had crappy screen technology. And the crappy screen technology we tried to emulate inside all the effects of the game. This is like UI designers and artists like to call this the metaphor of the game and the UI metaphor. So they said we look through a device. There is a control. There is some commander up there on a satellite, and he's looking on everything. So he's looking on a screen, and the screen should be CRT. So we put some lines. By the way, those lines are the same that draw the grid. Then they said, yeah, but the monitor is, everything looks better with rim lighting. So we put rim lighting on top. By the way, we still haven't subtracted anything from this picture. And then there was like, well, this screen isn't shitty enough. Let's add, yeah, this is not really visible. What this adds? This adds a scan line because it's a CRT monitor. No, this one has the second line. This one just adds noise, which is deleted by this projector because, as we said, crappy monitors. Scan lines because it's a CRT TV. And then the effect was still too busy. Just fade it out from the bottom up. And once you play it, it moves. It's quite pretty. And they, at some point, like we made it. We made this to be configurable by artists, and they started using it for everything. Like at some point, there were like 100% of the items of the geometry on screen was with this effect with different colors. So yeah, they had to tone that down. Other things that we have actually made in games are this is from Stranded Alien Dawn. We needed to build a grid. This grid uses something which you can Google. It's called Squircle. You always want those soft feathered edges, but by the way, this doesn't use the grid approach from previously because it's the other one needs to be a full screen effect, and they wanted to cover the separate parts. So this is actual geometry, which is placed on the ground. And there is but this uses the sign distance field thing, where you know what's the distance from the center to the edge, and this way you make it glow. We actually shipped a game with this. We shipped a game with the previous thing too. And we shipped 2 games with this, which is like a holographic effect. This uses the grid shader, but when we did this for Surviving Mars, we noticed that the effect is too busy. Then we made the lines thinner, and I was showing it to one of the designers, and he was like, I need something more, make it blue. And once we made it blue, he was like, oh, this is a hologram, but it would be even better if you do 2 sets of lines on top of one another, so that it can look like paper for drawings. So, yeah, we ship 2 games with this. And this is really cheap on production because previous games like Tropico had to do a bunch of artist work so that you can display the building process. Those games just show a line, and it is unique, so it can be a little bit cheaper, but still surprise people. Yeah, those are my bonus sites.
Great, thank you very much. Are there questions in the audience? Oh, there's one. Thank you. Just let me reach.
It's mostly about the presentation because the slide isn't very, the projector isn't very good. So can you make the slides available so that people can check out the effects?
They're available, but it is hard because this is a 1 gigabyte sized presentation. I can't upload it to GitHub. I'll post a link, or if you write to me at Haemimont Games, I'm going to send you a Google Docs link. I'll actually send you links for the shader toy too. Everything is available. You can steal code, do it. I'm doing it too.
Cool.
Thanks. Any other questions? There's one.
I just wanted to mention, if you want to anti-alias SDFs on any surface, you can take the hardware derivative of the UV, and that's the change of the UV over a pixel, and you can use it to get good anti-aliasing in most cases on triangles with SDFs.
Like, what's the difference between the what is why
the grid shader? To be honest, I didn't understand it.
Wait a second. Yeah. Come on, stop. Like this?
I cannot read that.
Yeah, by the way, don't take the code from the presentation. I actually implemented it in Shader Toy after making the presentation. There are typos, like these subtractions shouldn't be here. Yeah, but this is in 3D, doing the thing that you said, but you can do it in 2D too.
Yep.
Just on your UV and do a bunch of samples.
Super sampling?
Yeah, it's pretty much super sampling.
You don't need that with SDFs if you take the hardware derivative, usually.
Yeah, actually. Yeah, let's discuss it after the presentation.
Okay.
I need it written down, yeah.
Thank you. Any other questions? All right, doesn't seem so. Thank you very much once again.